Alright, I'm getting ready to make the hold down clamp for my compound. I've got my 1/2 inch plate marked out and squared up. I've marked for the center of the hole. Here's the piece I'm replacing. You can see this plate's a lot bigger and a little bit thicker. What I plan to do is try and remove the bulk of the material with a 2.5 inch hole saw, and then I'll use a boring bar to go from there. I'm not sure how well this hole saw is going to cut, but we'll give it a shot and find out. I'll go ahead and drill drill and ream a 1/4 inch hole here, so I'll have a smooth surface on there, so I can use my dial indicator to set this up in the fore jaw, and then I'll drill it in the lathe. Well, it took a little while, but I finally got the hole drilled in there, and we'll get ready to put the boring bar on. I've got a 2-inch travel magnet back on the dial indicator that I put on the way and up against the side of the carriage, so I've got it zeroed to the front of the plate. And then let me go give myself some clearance here. I've put a mag block on here, so when I get to the depth, I'll feel it hit that, and I can also watch the dial indicator to know when I'm close, because I'll use the power feed until I get close to depth, and then I'll cut the power feed and feed the last little bit by hand, and I'll feel it hit that magnet. This isn't a super rigid stop, but as long as you're aware it's coming up, because obviously if you turn the carriage crank, it'll push that magnet, but it's strong enough to let me feel it hit, and I can get a consistent depth on each pass. And then on the final, I'll probably run a cleanup cut across the face of that, about 5 thousandths deep. Okay, I've got the new plate mounted on the compound and clamped to the cross slide, and I'm just going to go ahead and get the outside corner holes marked. I'll go ahead and drill those, bolt it down with those, then I'll mark the center two that are under these clamps and get those last to make sure everything still lines up. Well, I've got the hold down for the compound just about finished. I've got it counterbored on this side, and I made some 100 thousandths thick just mild steel washers to go into these counterbores, and they sit just a little bit proud. So that when the bolts go in, the hex head bolts, the hex doesn't dig into the surrounding plate and chew it up. The reason I counterbored these rather than just have them sit on top is because there wasn't enough clearance under the compound so it can swing freely over the bolt heads. With this, and having taken the bolts and turning the crown off of them, taking about 25 thousandths or so off the top of the bolts, I've got good clearance. So those just sit in there, and there's enough room above them for the compound. On the underside, I've started to notch this out. I cut the two sides with a hacksaw, and then I've gone in with a cut-off blade on my 4-inch grinder and just started nibbling away at this. I'll do as much as I can with the grinder, and then I'll come in and clean that up with a file. That's so the degree settings can be visible through the front here. So I'll do a little more cleanup on that and come back. Well, I've got the window cut for the degree marks. I started out with my angle grinder with a cutoff wheel, and then I switched over to my little rotary tool with a cutoff wheel to get closer, and then finished up with a file. But now it's set up where you'll be able to see the angle marks through the window. Okay, with the compound upside down here, you can see how this goes back together. I made this tolerance a lot tighter than the original. Other people on the forums talked about getting that slop out of there so that chips can't get down inside there. I really hadn't had any problems with it, but thought I might as well. So that's a lot closer, probably only about 10 thousandths play in that. The last weak point, or potential weak point, is where this bolts down only uses 3 bolts, and this is where the clamp holds against the cross slide to keep the compound from rotating. Other people have put 3 additional bolts in there, and I think I'm going to do the same while I've got it apart. That should be about the last link in stiffening up the compound. Okay, in a perfect world, I'd have a mill with a rotary table, and I would exactly calculate this layout. In my world, that's not the way it works. So what I've done is just laid it out with calipers and dividers, and it's close. It's not going to have to be perfect as long as I align this correctly when I mark the next 3 holes. That's the only way. That's the only rotation it ever needs to be in when it's mounted. So if it won't go in a different position and bolt down, that's fine. So what I did was I took the measurement from the inside to the inside of this hole here. I took the diameter of this, so I ended up taking the radius of that hole plus this distance, set my calipers to that measurement, and used that to scribe the bolt circle on all 3 locations. Just scribed it straight off my caliper. And then I laid out the first hole by finding the distance to the edge from that bolt circle to the edge of the hole on either side, or as close as I could, and I put a punch mark there. I'd calculated the cord distance, so from there I just used that punch mark to mark across that bolt circle and that bolt circle, put my punch marks on both of those, and I can walk this thing all the way around and hit my punch marks. So I know my 120 degrees is correct between each hole. Now whether or not the bolt circle is perfect, again, it probably won't matter. I've put a mark at the 0 degree mark on the wheel, and I put a mark on my compound to make sure that I don't put this thing in the wrong position when I mark my holes. I want to make sure that it's where it's supposed to be. Once I've drilled and counterbored these, or at least drilled them, I'll go ahead and punch my marks in here. I'll drill and tap these holes, counterbore these, and bolt the thing on, and it'll be ready for final assembly. Okay, I've got my other 3 holes drilled, got them chamfered, counterbored, chamfered on top of there, ready to go. The one thing I did have to do was drill the new set of holes a little bit larger than the others. I'm working in imperial, not in metric, so even though I'm using metric bolts, I don't have metric counterbores and metric drills, so I had to find a drill size that would fit my counterbore, which was about 20 thousandths larger than the existing 3 holes, which shouldn't be a problem. The original 3 holes will position it, and then these 3 will just lock it down tighter. So I'll go ahead and transfer these holes and get ready to drill and tap the compound. Okay, this time we've got our lock plate on. I haven't fully reassembled the compound yet, but I just have these bolts in here finger tight to where they just are barely off the plate, and I can turn the entire 360 with the compound and not have any clearance problems with the bolt heads. I almost forgot the last item. I took the T-nut that came with the Grizzly lathe, and I went ahead and drilled it out and tapped it for the new tool post. If I ever need to go back to the old tool post for some reason, I'll just order a new piece and replace it. And it gets to live in its own little private tool drawer in the cabinet under the lathe. Well, that pretty much does it for this round of modifications. I hope to be doing some upgrades in the future as time allows to improve the capabilities of the machine even further. So hopefully I'll have some of those out in the not too distant future. Thanks for watching.